Hi there, in today's video we are learning about the hypothesis testing, and before we move towards hypothesis testing you should know what does hypothesis mean. Hypothesis means a claim or a statement about the population parameter like mean, variance and proportion. So if you know how we denote mean we denote by letter mu. Okay, variance is sigma square, and sigma is standard deviation, sigma square, and proportion is p. Okay, so this is so a claim or a statement about the population parameter like mean, variance, and proportion. So what does population mean here? Population means if in a class there are four students like student 1, student 2, student 3 and student 4. Out of 4 I have randomly selected one student. Suppose this student I have selected. So this will be a sample. Okay, and whole class is population. Okay, whole class is population. Okay, now, so you can test a hypothesis about a population by carrying out an experiment. So how we can test hypothesis? We can test a hypothesis about a population by carrying out an experiment. Yeah, okay, or taking a sample from a population. The result of the experiment that is calculated from sample is called the test statistic. So this is really important. The result of the experiment, whole this process is called experiment. Okay, in this experiment I have finalized this sample, and on this sample we are going to do this test, and that's called test statistic. Okay, I hope these definitions are clear. So hypothesis is a claim or a statement about the population parameter like mean, variance and proportion. Now let's see other things. So in order to carry out the test, you need to form two hypotheses. First one is called null hypothesis. Null hypothesis is denoted by the letter H0, and this is the hypothesis that you assume to be correct. We always assume that null hypothesis is correct, and with our test statistic and our test, we are going to find whether null hypothesis is true or not true. Okay, whether we are going to reject it or accept it. Yeah. Similarly, the alternative hypothesis is denoted by the letter H1, one is suffix here, and this tells you about the parameter if your assumption is shown to be wrong. And one thing I want to tell you here, that is, okay, that is, we always put equal sign with null hypothesis. If suppose example, this is example one, I'm going to write down here. So example one, H0 such that if probability is 0.2, it is just example, probability is 0.2. Okay, so we need to find H1 alternative probability. It can be greater than 0.2. Okay, or you can say alternate hypothesis less than 0.2, or we can say another alternative hypothesis that p is not equal to 0.2. On the basis of this, we finalize whether it is one tail test, two tail test, or left tail test, or right tail test, or two tail test here. So what I am trying to say here, if you see there is a equal sign, so null hypothesis always have equal sign, and if you see here is greater than sign, less than sign and equal, not equal to sign. So we will never put equal sign with alternative hypothesis. I hope this thing is clear. Okay, so next things we are going to discuss about the significance level. So significance level, it specifies the size of the rejection region where null hypothesis should be rejected, and we call this region as a critical or rejection region. So if I can show you with the help of example, just you need to understand the definition first. I repeat, so significance level, it specifies the size of the rejection region where null hypothesis should be rejected, and we call this region as a critical or rejection region. And critical value is the first value to fall inside the critical region. So once you understand the definition, things are not clear. We'll see one by one. Yeah. So if we are taking example of let's take two-tail test, right? Let's take example of two-tail test. So for two-tail test, we let's take significance level is alpha. Okay, so this is for two-tail test, and when we need to do two-tail test, when alternate hypothesis is not equal to something, yeah, then we do two-tail test. So here, uh, if significance level is alpha, yeah, so we will divide it by 2, so alpha should be divided by 2, so alpha by 2 will be here and alpha by 2 will be here. Okay, is that fine? So this region, this red region is called the rejection region, or we call it critical region. So we can write down here CR stands for critical region, and this is also critical region. And the middle part is here, we can say this is green part, accepted region. So here we can reject null hypothesis. In this region we can reject null hypothesis. Okay, so reject HO. Here also reject HO. HO means null hypothesis, and here do not reject. So here do not reject. So let me change the color. So do not reject. Do not reject HO. I hope things are clear. Okay, let's see another example. Okay, so this is for the two-tail test here. I can explain you clearly now for two-tail test. I'm going to explain the same thing again neatly. So when you are going to do two-tail test, so two-tail test is when null hypothesis is not equal to. Okay, so then alpha is our significance level. So I'm writing here SF significance level. So for two-tail test, we can divide alpha into two parts. So this area will be alpha by 2. It is exactly the same diagram which I've explained. I'm explaining here neatly, and this is also alpha by 2. Okay, so in this region, this red region, you need to reject alternative hypothesis. So here we can reject HO. Here also we can reject HO, and in the middle part, which is green part, like this one, I'm just shading it. Okay, so here do not reject, here do not reject HO. So do not reject. So it means except we don't write, so we write down do not reject. Okay, so this is for two-tail test. And you know when we need to do two-tail test, when alternative hypothesis where P is not equal to something. Yeah, so let's go for another example. Okay, so if our alternate hypothesis is P less than something, yeah, here it can be something, yeah, so P is less than, then because it is towards the left hand side, then we can say here left tail test. So in this case alpha is not going to be divided by 2, so this will be our alpha. This region, this is alpha. So in this region, this red region, again same thing, you can reject HO, reject HO, and here in this green region do not reject, right? So here do not reject. Okay, let me write down here do not reject. Okay, so left tail test. Similarly, a right tail test, then what will happen now? Then alternate hypothesis will be P greater than something. Here something. So it will be a right tail test. Okay. So for right tail test, this will be our rejection region, right? So in this alpha will be here, and here we are going to reject HO, and the middle region will be green. Here do not reject. Okay. So do not reject. Is it fine? And if test statistics fall in the rejection region, we reject HO. So remember, I can write down here, um, if test, this is our rejection region, red one. If test statistic falls in the rejection region, falls in the rejection region, okay, we reject HO. That is null hypothesis. We reject HO. Remember this thing, yeah. If our test statistic falls in the rejection region, like this red region, okay, so then we always reject HO. Okay, I hope things are clear now. Okay, let's do a couple of questions, and we'll find whether it is one tail test or two tail test here. So here's a question for you now. And remember one thing, I have highlighted this point here, important points. Claim with equal sign is null hypothesis here. So for each of these questions, state whether the hypothesis given described is a one-tailed test or two-tailed test. Now please pause the video and have a go. So if you see here, welcome back. Here P is given 0.8 and null hypothesis is 0 point greater than 0.8. So it is definitely a one-tail test. One-tail test. Okay, and here it is P is greater than 0.8, so definitely we are going for right side of test, right tail. Okay, now here P is 0.6, so we need to see alternative hypothesis. So if you see here there is a not equal sign, so definitely it is a two-tail test. Okay, two-tail test, it means our significance level alpha will be divided by 2. So it will be alpha by 2 here, and it will be alpha by 2 here. Here it will be like this. So alpha will be here. Now here P is less than 0.2. So it is one tail test. And in one tail test, definitely it is a left tail because it is a less than sign. So left tail test. So in this case, diagram will be like this. So alpha will be here. So you need to remember one thing, significance level alpha will be divide by 2 when you are doing two tail test. When you are doing one tail test, whether it is right tail or left tail, then alpha remains alpha. Okay, I hope things are clear. So this was my first video. Now in my next video we'll do couple of questions. This was just introduction of hypothesis testing, and we'll do more questions in my next video. Till then, goodbye, thank you, and thanks for watching.